All right, guys, so today I'm going to be going over factoring binomials. And I have written here for us that when factoring binomials, we need to think of these three types. Now, I say that because we have simple binomials, we have difference of squares, and sum and difference of cubes. But I always start by treating all of them as a simple binomial. And the reason for that is you always start a simple binomial by looking for the greatest common factor, which we do anytime that we're factoring, okay? So here I would see a 3x squared plus 6x. Well, I know that 3 goes into 3 and 3 goes into 6, and that's the greatest number that goes into 3 and 6. We can't say 6 because 6 does not go into 3. 3 goes into 6. So 3 is our greatest number, but we're looking for the greatest common factor. So let's look at the x's. Does each of these have at least one x? Yes, this one has 1 and this one has 2. So my greatest common factor here would be a 3x, and I would factor that out. And that's all I would do with a simple binomial. With a difference of squares, we need to check two things. So first, we need it to be difference, and that means that this right here must be a subtraction. And the second thing is squares. X squared, this is a perfect square, perfect, and 9 is a perfect square. That means that there is some number squared equals 9. What number squared equals 9? 3. So I could have this as x squared minus 3 squared, and that's why it's difference, which is subtraction, of squares, because each part of this is a perfect square, okay? And then the third one is sum and difference of cubes. So the reason it's sum and difference is because this number here could be addition or subtraction. That doesn't matter. The most important thing is that they both have to be cubes. So what number cubed equals 8? I always make like a list for myself when I am like first thinking about these. You know, it's been a year since I've kind of looked at this. Let's see. 1 cubed equals 1. 2 cubed equals 8. 3 cubed equals 27. 4 cubed equals 64. 5 cubed equals 125. 6 cubed equals 216. And I could keep going, but these are the typical ones that we see. So we just need to check, is 8x cubed a perfect cube? Well, 8 is a perfect cube because it's right here. Let me highlight it for us. 8 is a perfect cube because that would be 2 cubed. So this would be 2x all cubed. 2x all cubed minus, and is 27 a perfect cube? Yes, 27 is actually 3 cubed. So I could write this as 3 cubed. So if I look at this, I have 2 cubes, right? This is 2x cube, and this is 3 cube, and this is the sum or difference of it. So I'm going to actually fill in these blanks here. Here, here, and here at the end of our lesson, because I want to go through some examples with you guys first and then go back and fill this in. So let's get started on example 1. So I said I start all of these as if they were a greatest common factor. So let's do that. Let's start by looking at example 1 here and asking ourselves what number goes into both of these terms. So I have a to the 4th minus 16a squared. So I know that a squared goes into both of those. And if I factor that out, that means I'm dividing by it. So a to the 4th divided by a squared is a squared. In case you need to see it, let me just show you. That's a to the 4th, a squared. You could think of a to the 4th as a times a times a times a, and a squared as a times a. So if I were to reduce this, I would just get the a squared. Okay, so I took out the a squared, and I'm left with a squared. And then here I have 16, a squared divided by a squared just gives me 16. So now that I've done that, I need to look at these other options. So my other options were difference of squares or sum and difference of cubes. So now looking at what I have left, is this, well, this is squared, so I need to say, is this difference of squares? Well, that's difference. This is a square, but is 16 a perfect square? Yes, it is. So this is a squared times the quantity of a squared minus 4 squared. So if you think about it, this is a perfect square and this is a perfect square. Now, if we recall how to factor this, we would actually break this down as two binomials, and what multiplies to a squared is a times a. What multiplies to 16 in this case, or 4 squared, would be 4 times 4. 4 times 4 would give me 4 squared, which is 16. And that middle term has to add to 0. There is no middle term of this polynomial right here. So if I FOILed this out or distributed these two out right here, these parentheses, I would in fact get this here. So just a quick little reminder, difference of squares follows this pattern here. A times A, B and B, and one has to be a positive and one has to be a negative, or one has to be addition, one has to be subtraction in order for that middle term to add to 0. Okay, so that's what I have here. This cannot be broken down any further, this cannot be broken down any further, and so there I have my answer. Now let's try example 2. So example 2, again, always start by taking out the greatest common factor. I have 4 x's here and 3 x's here. I should automatically see that I can take out 3 x's. If there's 4 here and 3 here, the most that I can take out is 3 because I can't take 4 away when there's only 3 here, right? So if I take 3 x's away from here, I'm left with just x. If I take 3 x's away from here, I'm left with 9. So I would check, is this difference of squares or sum and difference of cubes? Well, x is not squared nor cubed, so it's actually neither. This is the final answer for this question, okay? You can always check to see if there's another greatest common factor, like maybe you didn't take out the greatest common factor, maybe you just took out a common factor. So x and 9 don't have anything in common, so I know that this is my final answer. All right, example 3. So I'm looking at this and I do not see anything that they have in common. I just have x cubed minus 1. Now I know that it's not difference of squares because that's not squared, that's cubed. So now I have to think about difference of cubes and sum of cubes. And so I'm going to write down the rule for this. So if I had a cubed minus b cubed, that would be equal to this here. So the setup for this is a, b, a squared, ab, b squared. Now the signs depend on whatever sign this is. So some say sop, some say soap. I always say soap where these two go together. So let me explain. So this is same sign goes here. So what sign was this? This was subtraction. This is going to be subtraction. This sign is always going to be opposite. So that means positive. Since this one was subtraction, this one's the opposite. And then always positive goes here. And so that's why some people call it SOP, because they take off this A and they just say it's same sign, opposite, positive. Okay, however you want to remember it. If it was addition, same type of thing where I have this setup where it's a, b, a squared, ab, b squared. And the signs still follow SOAP or SOP, where it's same sign. This is the same sign that's here. This is opposite, and this is always positive. So if I look at this example 3, I should see that this is x cubed minus 1 cube. And how do I know that that's 1 cube? Well, I'm trying to check to see if this number here is a perfect cube. If it was 27, I would say that this is 3 cubed. If it was 8, I would say 2 cubed. Well, this is 1, and 1 is a perfect cube. It's actually 1 cubed. So now I have this set up here where I have a cubed minus b cubed. So let's fill in what we have. A is x in this case. So everywhere I see an A, I'm going to put an x. So this is an x, this is an x squared, and this is an x in the middle. Now everywhere that I see a B, I'm going to put a 1. So this is a 1. 1 goes with the x here, and 1 squared goes here. And the reason I put the 1 in front here is because we always put our coefficient in front of our variable. So since this was a 1, I put it there, and my x is behind it. Now let's worry about our signs. Our signs are the same sign. So the same sign as subtraction is subtraction. Opposite, always positive. And now if I followed this correctly, I can simplify this. 1 times x is just x, and 1 squared is just 1. And that is how I factor a difference of cubes. Let's try another example. You know what? I'm going to actually change this example to be a positive just so I can show you what it looks like when you have a sum of cubes. So first and foremost, we always look for a greatest common factor. So let's find a common factor. I know that 2 goes into both of these. I wonder if 4 goes into both of these. So let's just take out a 2 and see where that leads me. So 2, that's going to give me 54x cubed. 2 goes into this 128. So you see how 54 and 128 are even? I can take out another 2. So I'm going to actually end up with 2 times 2, because I'm taking out another 2. So 2 divided by 54 is 2 goes into 5 4 times, remainder of 1, so 7x cubed. 2 goes into 12 6 times, and 2 goes into 8 4 times. So now if I'm looking at this, my common factor here is 2 times 2, so I'm going to just write that as a 4. Okay, now I'm looking at 27x cubed and 64. Well, I can rewrite 27, remember my list of cubes I made at the beginning? 27 is 3 cubed. And why did I put an x in there? Because it's 27x cubed. So it's 3x all cubed. That makes that. And 64 is 4 cubed. So I'm going to use that rule that I just taught you guys here. Okay, I'm going to use that here where this is equal to AB, A squared, AB, B squared. And let's fill these in. So A is 3x, so I put a 3x here. A is 3x, so I have 3x squared. A is 3x, and that's it. So now let's fill in my b's. B is 4 in this case. So 4, and 4 squared. So let's fill in our signs. Remember, soap or sop, same sign as this makes this a positive. Opposite sign makes this subtraction, and always positive makes this positive. So I'm going to reduce this. I'm going to get a 3x plus 4. 3x squared is 3x times 3x. That's a 9x squared. Then I have 3x times 4. Negative 3x times 4, so that's a negative 12x. This term right here, I got negative 12x. And 4 squared gave me 16. Now, is that my final answer? No, and hopefully you caught that. We took out a common factor. Whoops, there we go. We took out a common factor at the very beginning. That common factor is part of our answer. Okay, our question wasn't just this. This green part is the answer for just this. We also need that 4 we took out at the beginning. So going back up to these boxes, I hope that you can fill those in based on what the examples I just did. Good luck, guys!